My name is Carsten Bock, and today I'm going to talk about the importance of cloud-native core services in a telco world. Let me quickly introduce myself. My name is Carsten Bock, and I'm the CTO and founder of NGvoice. I am very much a voice over IP veteran, and I've been working on voice over IP for more than 20 years by now. I'm also a very active member of the Kamaili open source community. And before that, I was working for Telefonica in Germany, where I was working with the usual suspects, such as Ericsson, Oracle and Broadsoft and their IMS core. Now, who are we? Who is NGvoice? I founded the company 9 years ago, and initially we were a very small team of voice over IP enthusiasts and IMS evangelists. We believed in IMS while it was still a niche product, while nobody believed in IMS. Nowadays, IMS is a standard component in any telco environment. It's a component in 4G, it's a component in 5G, in all modern networks. 2018, David Bachmann joined our company in order to help us to commercialize our product. We also received a significant investment from Lansdowne Partners. So, what do we do? What is NGvoice doing? We initially started off with implementing an IMS core. We later added an HSS for doing provisioning, and what would life be without charging? So we also added an online charging server. When people talk about voice over LTE, they quite often talk about voice over Wi-Fi. So in order to facilitate that, we also added an ePDG to provide voice over Wi-Fi. We added a small PCRF because as soon as you want to launch a Volta service, you also need a PCRF. We added a whole bunch of application servers, starting from the IPSM gateway for legacy SMS, from a TAS server for telephony application services, for SLECC for the handover from 4G to 2G, and we also even added lawful intercept because it's a mandatory requirement in many countries. So now let's have a look at the challenges of a modern telco. Let's be honest, friends. Who of you has not been using WhatsApp, Skype or any other OTT app for making phone calls in the last couple of weeks? Even my mother started calling me on WhatsApp these days. Data usage is exploding, the ARPU is decreasing, so all of this puts a lot of pressure on the mobile network operator. In order to be competitive, he has to be very price sensitive. Let's have a quick look on how software telco infrastructure looks today. When I was working for Telefonica, the Ericsson IMS and all the IMS infrastructure we had were hardware boxes with very little software parts in it. Today, all parts of the network is software. The IMS core obviously, the ePDG, even parts of the radio access network, the RAN, is becoming available as software. And even more important, all of these components are ready for large-scale deployments. Let's have a quick look at the market. The world is changing. I don't know if you followed the news recently, but Microsoft bought Affirmed Networks and Metaswitch. So Microsoft is trying to become a 5G mobile core supplier. They didn't show up as mobile infrastructure provider before. And the same is happening in Japan. Rakuten, the Amazon of Japan, is starting to build a new mobile network infrastructure provider, all completely based on software. And they all have one big goal. They want to build a mobile network fully cloud native. Now let's have a look. In order to build your mobile network purely out of software, you have basically two approaches. You can either choose virtual machines or you can choose containers. And likely, if you're looking ahead, you already started to virtualize your infrastructure. And if you really did go the distance, you already are looking at the advantages of being really cloud native. Of course, virtual machines or containers, it's a little bit a religious war. Both approaches have a clear fan base. Obviously, both ways have a pro and a con. If you run virtual machines, you have literally the freedom of choice when it comes to the operating system. And the machine can really utilize all the capabilities the system provides you. The containers, on the other hand, are very much bound to use Linux, and the functionality is limited to basically what the engine provides. On the other hand, if you virtualize the hardware, if you run virtual machines, you clearly have more overhead due to the virtualized hardware. Containers, in comparison, have very less overhead and they provide more throughput. So, of course, containers are the very best alternative when it comes to virtualization. And if you look a little bit at the structure of all of this, then it's very clear. You see virtual machines have more layers between the server, between the CPU and the application. Containers, on the other hand, have less layers, which of course produces less overhead. And if you look at science, if you look at scientific research on this, there's a very interesting study from IBM research, where they clearly proved that containers have less CPU load on the same task compared to virtual machines. And the same basically applies for memory utilization. So containers clearly show a way better hardware utilization. So now let's look at the microservices in the telco world. It's time for DevOps. Of course, if you run a mobile network, scaling remains a challenge. You need to scale your service to the user behavior of your users. And this is even more important in a software world. In order to leverage all the advantages the containers bring you, the key is to slice the services into smaller pieces, so-called microservices. There are various reasons why you need to introduce microservices. Clearly, scaling depends on the service. If you look at network attachment, this is very likely evenly distributed. However, this may not be the case for supplementary services, and especially it does not apply for special situations. The scaling requirements evolve together with the provided services. So the scaling really clearly depends on the service that you are providing. It needs to be granular enough so you can scale on demand, but on the other hand, it should not be too granular in order to keep it manageable. Now let's have a closer look at microservices. You need to manage your microservices. And you really need an implementation of a real DevOps approach, especially when it comes to automatization. You need to decompose all your existing services into microservices, so you can really scale your resources independently. The management and all the configuration of all your services needs to be automated and simplified. Automatic lifecycle management needs to be implemented, and also portability is essential. We need to scale in public and in private cloud. Of course, one key part is you also need to choose an orchestrator. There's one de facto standard around it, that's Kubernetes. Kubernetes is the de facto standard orchestrator for every public cloud environment. It's available on AWS, Red Hat, Azure, Google Cloud, Oracle. Basically, you name it, almost every provider runs Kubernetes. We have to look at the key principles of automation. You really want to avoid manual intervention. It's really important. You want, of course, automate the onboarding and removing of resources. And of course, you don't want to have any manual intervention in this case. Of course, another key objective is that you need to watch your performance of the according systems. You need to benchmark them. Why do you need to automate this? Very clear, it's very obviously. The orchestrator needs to add and remove resources. By doing this, you get to self-scaling of your services. You want to match the demand of your subscribers, and you don't want to design and plan your platform just for maximum usage. Also, very clearly, you want to enable self-healing of your platform. Trust me, I've been there, I've done all of this. You don't want to get up at night just because a service failed. You need to automatically replace failed resources. And of course, you always need to be aware of what's happening on your platform. So you really need proper monitoring of your platform. Let's quickly do a hands-on example. You need to automate configuration and service discovery. DevOps is the key to this. I've taken here an example of an HSS implemented by a big vendor. And you clearly see there's a lot of manual configuration going into this. Now, if you look at Kubernetes and how Kubernetes was designed and what people thought when they implemented Kubernetes, it's very clear it was built for web services. And of course, this is very handy for web services, obviously, and it may be even handy for the 5G-N interfaces. But let's face it, it's less handy when it comes to voice services and 4G. In order to work with this on Kubernetes, you really have to focus on DevOps. And if you look at many legacy implementations, it's very clear that all of them require manual configuration. And this needs to be automated in order to provide automated scaling. And only if you have a proper DevOps team, the DevOps team will automate the configuration of the resources and services. All of this brings you a very new flexibility. If you are implementing all these levels of automatization, you can really move your capacity from cloud to bare metal. In our case, we're using Ansible and Terraform to automate the deployment. We're using Rancher to deploy Kubernetes. Obviously, we use Kubernetes for the whole infrastructure. And all of this allows us to really migrate our services from bare metal servers into the cloud, seamless, without any service interruption. Why we are talking about cloud native services? Why do I bring up bare metal servers? Most likely, your voice, your telco infrastructure carries sensitive data, authentication data, which you might not feel too comfortable with sharing that in a cloud. So there are reasons why you still need some bare metal servers. However, there are also less critical servers which you may use during busy hours. The whole thing only makes sense if you have a proper deployment process. You need to think about continuous integration and continuous delivery. And you need to make sure that all your processes ensure continuous solution improvement. Now let's look at two real-life implementation examples. Of course, we know about scaling voice. And when we're talking about scaling voice, we want to meet the real-time demand, and we don't want to meet potential demand. Trust me, been there, done that. If you look at our signaling processor, one signaling processor can easily handle around 500,000 subscribers. If you followed my presentation so far closely, you might remember that I mentioned that during busy hours we have around 11% of concurrent calls, which would result in 55,000 concurrent sessions. If I look at our media worker, it's very clear that the media worker, the capacity depends on the scenario. As soon as we need to do transcoding, the number goes down to 2,000 sessions per unit. If we don't need to do transcoding, it's something like 20,000 sessions. So it's really a huge difference. And what you clearly see, just do the math, we clearly need more media workers than we do signaling workers. Also, if you look on what these systems do, it's very clear that they don't handle such critical data as other core components might do, so it's very safe to run them in the public cloud. Now let's also look at scaling the HSS. And of course, you need to think about scaling single interfaces. You might see that the usage on the S6A interface goes up as soon as more people attach to 4G, which will likely happen these days. On the other hand, you might see that S6D, the interface for connecting legacy networks, might go down because people don't use 2G, 3G anymore. Of course, as more and more voice over LTE handsets arise on the market, you might want to scale CX and DX interfaces up just to cope with new voice over LTE and voice over new radio subscribers. And the number of examples go on and on. So you really see that you need to scale each interface of an HSS independently, just to utilize it in the best possible manner. And what's the result of all of this? It's very clear. You can utilize any cloud on demand during busy hour. Traditional telcos tend to provide the hardware just to deal with all the maximum peak capacity that they expect on their network. You don't need to do that anymore. You can simply utilize the public cloud at the moment when you need it, bringing you huge cost savings and other benefits. Now let's take a quick conclusion. What does all of this mean? If you want to build a more intelligent cloud-native network, this needs to be done right. Just virtualizing your existing services won't help. It won't do the job. You need to think about optimization and you need to do proper orchestration. This is really essential. You need to implement the main DevOps principles. This is the key to success. And very clearly, cloud-native core services is the answer, because it will bring down your costs and it will increase your flexibility. And still, you keep the same really good availability. Those are the key points. Thank you for your time, and don't hesitate to reach out if you have any further questions. Thank you.